Hello class. Now that we've had our whirlwind tour of soil formation factors, remember CLORPT, C-L-O-R-P-T, which stands for climate, organisms, relief, parent material, time. Now the power of CLORPT held sway over soil science for many decades. And on the outset, human activity could be put within the organism part of CLORPT. However, soil science came about at the end of the Industrial Revolution and didn't take into account the things yet to come. So, again, on history, this is Vasily Vasilyevich Dokuchev, the father of modern soil science. He published his work in 1883. 1883, basically the end of the Industrial Revolution. And then we get Hans Jenny, who popularized it into CLORPT, and he published his book in 1941. Now, within this 6-year gap, there's been an important invention whose effect has not yet been fully realized. In let's say like 1913, so right about here, we have the invention of the Haber-Bosch process, or the official industrialization of the Haber-Bosch process. The Haber-Bosch process is an industrial way to synthesize atmospheric nitrogen into a plant-available form. And as you can see, it's just 30 years before Hans Jenny popularized soil formation factors into CLORPT. And so the true effect of what Haber-Bosch did has not yet come to pass. To really see the effect of Haber-Bosch, we need to roll forward to our present day. And so if we look at the population of the planet from about the 1900s, we have about 1 billion people. That's probably still, maybe enough that we're still part of organisms within CLORPT. However, fast forward 100 years, 110 years, we've now got 7 billion people on the planet. That's an increase of 6 billion people. Are we still the same organisms? Are we still exerting the same minimal influence to be comparable to the rest of biology on the planet? Is our influence on soil the same? Well, some researchers suggest no. In 2010, some researchers led by Richard V. Puyat proposed amending CLORPT to recognize this increasing effect that humanity must surely have on soil. This is the formula that Puyat et al. Came up with. Function of A, CLORPT. So CLORPT, still the same. Climate, organisms, relief, parent material, time. The difference here, this function A. A stood for anthropogenic, which itself means human-caused. So now, rather than humans being part of the organisms that affect soil in the form of CLORPT, we now have humans withdrawn out of CLORPT, CLORPT being the natural world, and human being the artificial effect upon it. Now we're going to examine how humans can affect each of these sections. All right, so the first part, climate. How do humans affect climate? Well, in the simplest manner, if we have a plant here, it's subject to natural climatic variations. But you install a hoop house, you put some plastic over it, and now suddenly this is excluding rain and it's increasing the temperature. Both of these are going to dramatically change how this plant grows, and subsequently that's also part of this organism part that influences the development of the soil below. So I alluded to it already, but how humans affect the organisms is in large part we're choosing how these plants grow, what plants grow, when they grow. And we're doing this partly through tools like a soil knife. You're getting in there, you're planting you're planting a plug of whatever crop you want to grow. You're digging out any of the weeds that you find. So you're affecting organisms by enacting your desires. The other way humans affect organisms is, of course, choosing what plants grow. So taking your seed packets and putting particular plants in that soil is going to change that soil, even slightly, to how it would have been if you had left it alone. And so again, we're seeing human management overriding natural factors. The organism that was growing there, I have replaced and put in my own. Now to talk about relief or topography, we've really got to zoom back, and my drawings are not going to be sufficient. So let me get them out of the way and we'll look at a picture. All right, so for modifying relief or topography, in our modern times we've got these huge machines that can do just insane amounts of work. So look here, look at how big this scale is. Look at how much is being changed. Look at the elevational changes. They've got this big dip through here. They're piling this stuff up here. And all this is being done by 4 people. So it's not that this couldn't occur in the past, and surely large earthworks were undertaken. But the speed and the ease with which humanity can affect these changes is the reason that we need to take us out of the equation here and make us supersede the equation here. When we're talking about potting material, this again is up to the human management. And so when you're getting a bag of potting material, read its ingredient list. What you are pouring into your growing area is becoming the new parent material. So while the classic scenario was that parent material were the rocks below and they slowly weathered up to build soil, and that's all humans had to work with, we can now import material, whatever we'd like, and start using that. And because soil weathers from the top down, the most recent addition is actually the newest portion that is actively weathering. And so even if you pour this onto your site and it covers your surface, now what used to be there is no longer weathering, or at least weathering at a much slower rate. And this stuff here, that's the new source. That's the new parent material, at least until it expires and you're back to utilizing your native parent material down here. All right, lastly, time. Again, very difficult to visualize, but actually possibly the biggest thing that humanity affects. So again, looking at the digging that we saw, it's happening at such a speed. And so they're all natural factors which could occur. Erosion does occur. Mass transport of particles from one area to another does occur. But over centuries or decades, and sometimes, in a quick flash, but then it doesn't happen again. When humanity is out there digging and moving and pushing and never ceasing, this is where we're affecting time. We're making all these things happen at such an accelerated rate that it simply is not the same as a natural times table. All right, that's as far as we're going to take function of A chlorped. I very much encourage you to take more soil classes, but we just can't afford to go deeper right now. Next, we'll move on to some more anthropogenic factors. So we'll be focusing on this portion of the section.